Hello students, in this video tutorial, I will guide you on how to solve a non-parametric problem using Kruskal Wallis test. Given this problem, suppose that a principal is interested in the differences among final exam scores from red, white, blue, and black classes. The principal takes random samples of students from each of these classes and records their final exam scores as below. Test whether there is any differences in the scores obtained from these four classes. Before we go into the solution, let's analyze the data that we have here. It is not stated what kind of test to be used, so we have to determine from the type of the data given. So let's have a look at the data. So there are four samples with the sample size less than 25 for each of the sample, right? You can see for red sample, there are 6 data, and for white there are 5, for blue there are 7, and for black there are 6. So obviously all of them have less than 25. So these data fall into the category of non-parametric data. So in that case, we have to use non-parametric tests to evaluate the differences. Now let's have a look at the number of samples. There are 4 samples, and you can see from the nature of the data here, the samples are independent. So it means that it stands by its own. So having more than 2 samples and of independent data, the suitable test to be used in this case is Kruskal Wallis test. So in this problem, we are going to use Kruskal Wallis test in order to solve the differences between all of these 4 classes. Now let's solve this problem using Kruskal Wallis test. The first step is to set the hypothesis. Since there are 4 samples, so we have to include all of the 4 samples in both the null and alternative hypothesis. The null hypothesis can be written as mu red is equal to mu white equal to mu blue equal to mu black. Or in other words, there is no difference in the mean of all of the 4 samples. The alternative hypothesis can be written as mu red is not equal to mu white, is not equal to mu blue, is not equal to mu black. Or you can also write at least one of the means of the samples is not equal to the rest. The second step is to combine and rank the data. So what is meant by combine and rank the data here is we have to include all of the data and rank from the lowest to the highest. And we also have to apply tight ranks whenever needed. Tight ranks are applied for data that are similar, where they share the ranks and they are not written as usual ranks. Now let's have a look at the data here. So we start the first rank with 46, which is the lowest data, the lowest value, followed by 48 as the second rank, 49 as the third rank, 52 as the fourth rank, and so on. You can see that there are 263, so we have to apply the tight ranks. And the ranks that are supposed to be assigned for these 2 values are 12 and 13. But we cannot apply 12 and 13 as usual, so we have to find the tight rank, which is actually the average of 12 and 13, which is equal to 12.5. So we assign 12.5 to both of the values. The second tight rank is 14.5, which is assigned to the value of 64, since there are 264 values. Right, the same thing, we apply 14 plus 15 divided by 2, which is equal to 14.5, and that rank is assigned to both of the values. The third type rank is 20, which is assigned to the value of 70, because there are 370 values. So 20 is obtained by averaging the rank of 19, 20, and 21. And here we have to divide by 3 because there are 3 ranks, and the average value is 20. So 20 is assigned to all of these 3 values. So the following rank just follow right after 21, that is 22, where you can see that it is assigned to 73, right? And then 23, 24, and so on. Yeah, so the last rank is 24 because that's the highest value in this data. So that is how we combine and rank the data of all the samples. In step 3, we have to calculate the sum of ranks, that is SI, and also the sample size, that is denoted as NI. Now let's have a look at NI first. The sample size of the red group or sample is 6, and white is 5, and blue is 7, and black is 6. So this is based on the number of data for each of the sample, which can be counted. For the sum of ranks of each of the sample, for red sample, we have to sum up all of the ranks that are 4 plus 1 plus 11 plus 2 plus 7 plus 6, which is equal to 31. And the same thing to be applied for as white, as blue, and as black. So these are the values that we need to find from this step. In step 4, we have to calculate the H value given by the formula written here. So in order to find H, we need to find what are the NI values and also the SI values. And these values are solved in the step before. So the one that are in the boxes here are the values that were obtained from step 3. So by plugging in the values into the formula, we can find what's the H value. But before that, please take note that we also have to find the total number of the data, which is n. And n is obtained by adding all the number of the samples that are 6, 5, 7, and 6. And the total is 24. So we plug in the 24 into the formula under the symbol of n. And the rest for SI and NI that represent the values for each of the sample. So the final value of H is 10.71. In step 5, we have to compare the H and the chi-square values. But first, we have to find what is the chi-square value from the chi-square table. So in order to find the chi-square value from the table, we have to know what is the value of the degree of freedom, or V, which is equal to k minus 1, and also the alpha value. So since the number of samples, that is k, in this problem is 4, so the degree of freedom is given as 3. And the alpha value, since it is not given in the question, we have to define by ourselves. So the common value is 0.05. So based on this information, from the chi-square table, we get the chi-square value as 7.815. So this 7.815 is to be compared with the H value that we obtained from step 4, that is 10.75. So the step 6 is to make a decision. Based on the decision rule, we reject the null hypothesis if the H value is greater than the chi-square, which is the case for this problem. So In this problem, we have to accept the alternative hypothesis since the h value is greater than the chi-square value. Since the alternative hypothesis is accepted, we need to proceed with Bonferroni inequality procedure, that are step 7 to step 9. In step 7, we have to find the average of SI for every sample. SI bar is given as SI divided by NI. The SR bar for red is 5.167, white 11.5, blue 17.5, and black 18.83. In the 8th step, we have to calculate dij. The formula of dij is given as follows. dij refers to the pair that we can create from the number of samples provided in the question. For example, out of these 4 samples, we can create red-white pair, red-blue pair, red-black pair, white-blue pair, white-black pair, and finally blue-black pair. So altogether, there are 6 pairs. So for all of these 6 pairs, we have to find the dij value by plugging in the related symbols and terms. For red and white, we find the value of D as 1.48. For red and blue, 3.14, red-black 2.367, white-blue 1.45, white-black 0.78, and blue-black 0.68. In the following step, we have to find the critical value, or the Z value, based on the tile area given as alpha divided by k multiplied by k minus 1. And then we have to compare the dij with the Z value. The tile area for this problem is given as 0.00417. The Z value that corresponds to this tile area is 2.64, and we obtain this Z value from the Z distribution table. The decision rule is to reject the null hypothesis if the dij value is greater than the Z value or the critical value. So based on the dij values obtained from step 8, we compare each of them with the Z value, that is 2.64. So these are all the decisions that we have made based on the decision rule. For all the pairs, we accept the null hypothesis except for the red-blue pair, where the value of dij is greater than the Z value. So in that case, we have to accept the alternative hypothesis. The final step, that is to make the conclusion. So as a conclusion, we can state that at alpha equal to 0.05, there is no difference in the mean score between red and white, red and black, white and blue, white and black, and blue and black. But there is a difference in the mean score between red and blue classes. That's the end of today's tutorial. Thank you very much for watching. I hope you guys have learned how to solve a non-parametric problem using Kruskal Wallis test. For more video tutorials on statistics, please subscribe No Statistics No Talk on YouTube. Stay safe and have a nice day.